And we're back with another episode of What Are You Doing in Lab this week? This week, we're doing rocks. So I've brought you a little piece of my heart called Box Canyon. Box Canyon is a really cool place in Ouray, Colorado. It's one of my near and dear to my heart. It's one of my favorite places on this planet. If you ever have an opportunity to travel to Ouray, it is very, very cool. And what is so cool about the canyon that is Box Canyon is that there is what kind of unconformity is this? Have you learned that yet in your readings? This is called an angular unconformity because the rocks on the bottom are tilted and the rocks on the top are more or less horizontal. And so these rock layers here were deposited and then uplifted because we know rock layers are deposited horizontal. And so geologic activity, tectonic activity will have pushed them up. Okay. And then we have a huge discontinuity here where erosion has wiped away the surface of those rocks, eroding away long lengths of time. And then later on, very, very later on in this case, redepositing horizontal rock layers on top. Right here, right there, in this layer where we go from vertical to horizontal, there is 1 billion years missing, a billion years of rock time missing between here and there. Isn't that cool? It's a 1 billion year time gap in those rocks. Anyway, you are going to be identifying rocks this week. So let's take a look. Share my screen. So it's kind of weird, just talking to your computer instead of talking to real people. But that's an online class for you. Okay, so here is your course site. I already downloaded some stuff from it that I wanted you to see. So we're gonna scroll on down to rocks, open that guy up. Here is your workspace. Okay, so you're gonna open that guy, and that is this one. And so read through this. You're gonna use your book, your textbook. It has charts that help you identify features in the rocks so that you can come to the name of the rock. So you're using your book, your textbook for this. In the igneous, metamorphic, and sedimentary chapters, there's charts in those chapters that you are going to use to complete this lab, okay? And these are your rock names, and it tells you where the figures are. So figure 2.6, go find that guy. You're gonna find yourself some igneous rocks, okay? And then moving on, sedimentary, metamorphic, those are your 3 rock types, okay? Now, igneous rocks, we identify those based on their composition. Is it felsic, mafic, or intermediate? And from reading your chapter, you will know what that means. Felsic is light, low density, okay? Mafic is dark, high density, all right? Intermediate, in between, okay? Texture, is it coarse-grained or fine-grained? Is it phaneritic, big, or aphanitic, little? If it's big, it's an intrusive igneous rock. And by big, I mean, can you see the mineral grains? And if it's fine, meaning you need a microscope to see the different mineral grains, it's aphanitic, and it is an extrusive igneous rock. Now, sometimes you get both in this weird situation where a volcano is dormant and the magma chamber starts to crystallize big crystals because it's underground and the heat release is slow because the inside of the earth is warm. And so slowly the magma chamber cools down, and kind of like rock candy, the longer you let it crystallize, the bigger the crystals get. And so the slower the magma chamber cools down, the bigger the mineral grains get. And then all of a sudden the volcano says, I'm going to blow up, and it goes, And all that stuff that's already solid stays solid, but that liquid stuff hits the cold exterior of the earth and crystallizes almost instantaneously, making teeny tiny microscopic crystals. And that's how you get both crystal textures in a porphyritic rock, right? So let's look at our igneous rocks in the igneous rock folder and notice that I have given you some hints. So sometimes rocks, most often all rocks, okay, most rocks, have both felsic and mafic minerals, okay? Heavy, dense, dark, mafic minerals. Light, low density, felsic minerals, a mixture of the two. This particular rock that we're looking at has a mixture of the two. You can see a whole bunch of these dark things. You can see a whole bunch of these white and pink things. And then there's this like kind of grayish stuff, which is a felsic mineral. So the only mafic minerals that you have in here are these black bits, okay? So use your mind when you're looking at this rock and move the black bits over to one side. Do they make up most of the rock or very little of the rock? Whatever the rock is mostly composed of is where we give it its composition name of felsic or mafic. So if we move the dark bits and the light bits and we separate them in our brain, and you think like, well, the dark bits might only take up, you know, this region if I were to separate them, and then this other 3/4 of the rock is going to be light bits. Well, then it's mostly light bits. If it's mostly light minerals, it's felsic. Okay. So then this one's all light, felsic. What about this one? This one looks weird. Okay. I want you to look at this is a freshly exposed piece, which is a light gray. And then this is a portion, a surface of this rock that's been handled by the oils in our skin, which has caused it to appear darker, kind of like when you throw a pebble into a stream and the hue of the color darkens, okay? But it's all gray. The whole thing's gray, and gray is a mixture of black and white being felsic and black being mafic. So keep that in your brain when you're doing this one. This one, if we separate light to dark, well, it's about a 50-50 split. What's a mixture composition called? So a couple of things to point out here, all right? See how these ones are little and those ones are big? That's okay. They cooled in the same locality, whether above ground or below ground. Both of these rocks cooled below ground. You know how I know? Because I can see the grains. You can see them. I can see pink, black, white, gray. If I go down here, I can see white, black. If it's an extrusive igneous rock, you cannot see the different grains. They're too small. You need a microscope. You cannot see white versus black in this one. Too small. Okay. This one's tricky. This is way better in person. I'm just going to tell you, you can see them. Okay. You can see this white stuff. There's actually a little bit of green. And then there's like these black blady things that you can see. It's this one's tough. That's why I'm telling you. Okay. This one, you cannot see a difference. This is like this is so fine grained that it's a glass. It's not even technically a rock. Weird, right? It is an earth material, but it's not a mineral and it's not a rock. And you know why? Because it cooled so quickly that the atoms did not have the opportunity to orient themselves in a repeating pattern. They're just all over the place, just trapped, frozen in time in this amorphous mixture of glass. Volcanic glass, to be specific. Okay, so you get the idea. You can do this, okay? And then you're going to use your workspace and you're going to fill out your chart like this, like so. Okay. Again, the description is anything that helps you recognize the rock. You know, if you're like, oh, I've seen, hold on, where is it? Oh, I've scrubbed my feet with that before. Well, you know, there's your description. It's the rock I use to get the dead skin off my feet. That's fine. I mean, ideally, I want you to describe the rock like it's kind of like a white foamy looking rock. Okay. So moving on. Let's go back. We'll look at the other category. So then you have your, so you're gonna fill out the chart in this activity link, and then you're going to do your descriptions. I have them separate on purpose, okay? And then metamorphic rocks, fill in your chart, do your descriptions, and so on, and that's the lab, okay? Unfortunately, you don't get to hold the rock in person, but I saved you money, lots of money, by not requiring you to buy a kit of rocks and minerals that you may only use once. Now, if you are a rock and mineral enthusiast, by all means, go on Amazon, buy yourself a rock kit and a mineral kit and use it, okay? But if you're like, I'm just taking this class to get by and get my degree, I'm not gonna make you buy rocks that you're just gonna throw in the garbage later, okay? But if you're a rock and mineral enthusiast, go for it. They're fun. They're nice to see in person. They're nice to hold. You can really feel the textures, okay? Or if you want to come to campus and use the on-campus rocks and minerals, you are of course more than welcome to do that. There is a toolbox in each library on each campus that is filled with rock specimens that you can use to study from. Okay, so that's what I have for you today. And I hope you all have a good one, and we'll see you in the next folder.